Welcome back from the ad break, and let's continue with our lesson. So next we are going to be looking at those interior and exterior alternate angles. Now remember, when it comes to the alternate angles, those are the angles that occur on opposite sides of a transversal line that cuts two or more parallel lines. Now the interior alternate angles will be on the inside of the parallel lines, and the exterior angles will be on the outside of the parallel lines. And what we should remember here is that alternate angles are equal, but only if they are parallel lines. Let's look at which angles here are our alternate angles. Let's start with the interior alternate angles. Remember, interior means they'll be in between the parallel lines, but on opposite sides of the transversal. And when we are looking at angle A, it is inside the parallel line on one side of the transversal, and we have angle G, which is also inside of the parallel line, but now on the opposite side of the transversal. This simply means that angle A and angle G will be equal. They are interior alternate angles. They are not the only ones that are interior alternate. We have angle B and angle H, so they will also be equal because they are interior alternate angles. Now, when we're talking about exterior alternate angles, they are still on the opposite sides of the transversal, but they are on the outside of the parallel lines. So that would be angle C and angle E. Those are exterior alternate angles, but again, we also have angle F and angle D. They are also on the outside of the parallel lines on opposite sides of a transversal line. So that makes them exterior alternate angles, and they of course are equal. Let's look at a practical example. So it says they calculate the missing angles, or calculate the angles that are unknown. So we have the angle L, angle O, and angle N. And when we are looking at those angles there, we can see that they have a relationship with the given angles. We also have angle M. So let's start with angle N. So when we're looking at angle N, it is on the inside of a parallel line, on one side of a transversal, and this 60 degrees is also on the inside of a parallel line, but on the other side of a transversal. This simply means that angle N is also equals to our 60 degrees, and that is because that is an interior alternate angle. And only because AB is parallel to PQ, and that is what makes them equal. So let's look at our L. So when we're looking at our angle L, we have angle L there. It is on the outside of a parallel line and on one side of a transversal, and we've got 120 on the other side of a transversal, also on the outside of a parallel line. So that is going to say that angle L is equals to 120 degrees, and that is because of the exterior alternate angles. And this is simply because, or they are equal, only because of the two parallel lines, that is AB and PQ. Let's look at angle M. Angle M there is also an exterior alternate angle. So that means that it is equals to this other exterior alternate angle. So that means it is equals to 60 degrees. The reason is exterior alternate angles. And this is possible because of our parallel lines. It's always important to state why we're saying that they are equal. And lastly, we have angle O. So angle O is also interior with, angle O is interior alternate with our 120 degrees. So that means that O is 120 degrees. But from our last work, we can also see that O is vertically opposite to O. And because they are formed by two lines intersecting there, that also means that they are equal. But the reason that we are going to use here is because of the interior alternate angles. And let's not forget that it's because AB is parallel to PQ. So let's move on to when we have perpendicular lines, which is the next point on our concept map. So perpendicular lines are lines that intersect at 90 degrees. So for example, we have the CD, so it's CD, not AB. So we have line CD, and it is there perpendicular to PQ. And because they're perpendicular, where they intersect there, it forms a 90 degrees. So them intersecting at 90 degrees means that they are perpendicular. So as we can see there, D1 is equals to 90. Why? Because CD is perpendicular to PQ. And again, D2 is 90 degrees. Why? Because CD is perpendicular to PQ. So because of them being perpendicular, and we know that perpendicular means they intersect at 90 degrees, that means that those two angles there are 90 degrees. So let's look at an example here. They say FG is perpendicular to KL. Now find the size of K1 and K2. Perpendicular means they intersect at 90 degrees. So as shown there, we can already see that our K2, so our angle K2 is equals to 90 degrees. And our reason for that is because FG is perpendicular to KL. But again, our K1 is also 90 degrees because it is also that point of intersection. And we know that perpendicular lines intersect at 90 degrees. So it is also 90 degrees because FG is perpendicular to KL. And there we found the size of those two angles simply because we knew that those two lines are perpendicular to each other. Let's move on to the next question that deals with perpendicular lines. So it says there, calculate with reasons the missing angles of X, Y, and Z. So we have unknown angles there, X, Y, and Z, and we are supposed to calculate them. Now we have been shown here that firstly AB and PQ are parallel. And not only are we shown that they are parallel, but we are shown there that there is a 90 degrees, which is the angle of Y. And that's the one that we are going to start with there. And we are going to say that angle Y is equals to a 90 degrees there. And our reason there could be that we have been given. And because that 90 degrees was given to us, we automatically know that angle of Y is a 90 degrees. Now, how are we going to use our other knowledge of angles to calculate X and Z? So let's look at X first. Now, when we're looking at X and Y, they are on a straight line and they also share a common vertex. What does this mean? It means that X plus Y is equals to 180 degrees. And our reason for this is that these angles on a straight line are supplementary, which means that they add up to 180 degrees. Now, we already know that our Y is equals to 90 degrees. And we are going to use the additive inverse of 90 degrees to solve for our X, where we are going to say 180 degrees minus the 90 degrees. This is going to give us X is equals to 90 degrees. So there we can see that X is also equals to our 90 degrees. But because we were given that 90 degrees, we actually now know that ML and PQ are perpendicular, because perpendicular means they intersect at 90 degrees. What about that value for the Z? Now, when we look at the Z there, it is corresponding with the Y because they are in the same relative position and we have those parallel lines. So that means that Z is also equals to 90 degrees, and we can state as our reason there corresponding angles. And the reason why we say they are equal, it's because we can see that AB is parallel to PQ. And there we found the angles of X, Y, and Z. let's end off our lesson with problem solving or solving problems. And we have one diagram that looks complicated, but because we know our angles and we know our pairs of angles and how our intersecting lines form those relationships between the angles, then we know that we can calculate those angles. Let us now calculate with reasons all the missing angles. So those are all the unknowns, and that would be our angle A, B, C, and D, and also our angle X, Y, and Z. Now, the only angle that we have been given is 110 degrees. So that 110 degrees will allow us to calculate all the other angles. Now, let's start with our Y, because as you can see, there is a line PQ with a line AB, and that is forming two angles that are opposite each other. And because those two angles are opposite their common vertex, that means they are vertically opposite angles. So we can easily say there that Y is equals to 110 degrees. And our reason for that is because the angles are vertically opposite. And we know that vertically opposite angles, when they are two lines that are intersecting each other, then we know that the vertically opposite angles are equal. But remember, only when they are intersecting lines. Then we can go now and calculate the other angles. Let us calculate the angle of angle D. So when we are looking at angle D, we can see that it occupies the same relative space as the 110. And because there are parallel lines, we know that those two angles, not only are they corresponding, but they're also equal because of the two parallel lines. So D is equals to 110 degrees, and this is because of the corresponding angles. And of course, they are equal because LM is parallel to AB. So we know that that angle there is equals to the 110 degrees. Now that opens way for us to say that angle B is also 110 degrees. And why are we saying that? Because they are vertically opposite to each other. They share common vertex and they are formed by two intersecting lines. So vertically opposite angles are equal. Okay, so let us look at angle C. When we look at angle C, now angle C is co-exterior to the 110 that we were given. So this means that our angle C, when added to the 110 degrees, they should give us 180 degrees. Why? Because co-exterior angles, they are supplementary. So co-exterior angles, and they are only supplementary because AB is parallel to LM. So that means that our C here is going to be 180 degrees minus the 110 degrees, and that is only because we are using the additive inverse of 110, and our answer there is going to be 70 degrees. So that means that our C there is our 70 degrees. And if you look at our C and our D, they are lying on a straight line. And remember, the sum of the angles on a straight line is 180 degrees. Even though we calculated C and D using other ways, they are still equals to that 180 degrees. Let's look at angle A. And if we look at angle A, it is vertically opposite our angle C because they are being formed by two intersecting lines and they are on opposite sides of that common vertex. So that means that angle A is equals to 70 degrees as well. And our reason for that is because of the vertically opposite opposite angles. And because those vertically opposite angles are equal. And why are they equal? And they are only equal because they are formed by intersecting lines. Now we have x and z to calculate, then we would have calculated all our angles. Now when we look at our x, we can see it is corresponding, let's put that 70 degrees there for angle A, but our x is corresponding with our angle A because they are in the same relative position. So because they are corresponding and they are under parallel lines, that means that they are equal. So angle X is also 70 degrees. Our reason for that is because of the corresponding angles. And of course, only because LM is parallel to AB. And our last angle that we are going to calculate is our Z. And as we can see there, our Z is vertically opposite to our X. That means that it is also equals to 70 degrees. And the reason for that is the vertically opposite angles. And because those angles are formed from intersecting lines, then that means that they are equal. And that is how we used all our knowledge of the angles and the intersecting lines to solve for those unknown angles. Thank you for joining us for this lesson. I hope you enjoyed it as much as I did, and we hope to see you next time. Goodbye.